All right, so last lesson, we talked about how to prove that you have a parallelogram. Now we're going to talk about how you prove how you have different quadrilaterals. And this little chart here in the front should help you. To prove that you have a rectangle, you see you have three options. The first two options are the most common for sure. Require you to prove a parallelogram first. Then once you prove a parallelogram, if you have either one right angle or the diagonals congruent, that means you have to have a rectangle. Or you can, this is not common, but it happens sometimes, you can bypass the parallelogram route and just show, hey, if you got a quadrilateral with four right angles, it's got to be a rectangle. Okay? Actually, when you think about it, three right angles would be enough, wouldn't it? Then this will come back. On the right, it's asking us about how to prove a rhombus. So again, similar, you have three, to the rectangle on the left, you have three options. The first two, again, require you to show a parallelogram first. Then you show either consecutive sides are congruent or one diagonal bisects an angle. Or you can bypass the parallelogram part of it and just show that the diagonals are perpendicular bisectors of each other. If that's the case, you have a rhombus. And you see down here a square. To prove a square, you're going to prove that you have both a rectangle and a rhombus. A kite, you can prove it based on the sides. You know, the two disjoint pairs of consecutive sides congruent, or having one diagonal perpendicular bisector the other. Remember, if you have both, then you have a rhombus, which is actually a special kite. And then trapezoid, of course, is one pair of sides parallel. That gives you trapezoid. And then to get an isotrap, you have three ways of getting there. Show that the legs are congruent, show that the diagonals are congruent, or show either the lower or the upper base angles. Okay, so here's a proof we can do. So we're given a parallelogram. Okay, remember, that's a lot of information. I'm going to write down my given stuff, DBC and DCB. And I know that BD has to be congruent to DC based on if angles, then sides. My pen is a little bit weird right there. And then here I'm going to say that EA is congruent to BD if parallelogram opposite sides are congruent. And of course, you can see a transitive step coming here, right? So that means that EA is congruent to DC. Transitive. Now remember, this thing was a parallelogram to begin with, so we can say that ED is parallel to AC. Okay? And that's if P-gram, then opposite sides parallel. And then, you know, I guess technically this would be 7 steps. I'm going to do it in just 6. I'm not going to say it's a trapezoid first. I'm just going to go straight to saying it's a isotrap. AEDC is isotrap if one pair of opposite sides parallel and other sides congruent, then isotrap. All right, there you go. There you go. Give the most descriptive name for each. This would be good stuff for you guys to mess around with yourself. Give this a try. Give the most descriptive name that it has to be. Not that it could be, that it has to be. And check your answers with the answer key that I'm going to post. Okay, down here, this is a new type of problem. We're going to talk more about this in the next lesson too. But this is what we call a coordinate proof. Okay, it's not a two-column proof. We're doing this with numbers with a lot of algebra. Give the most descriptive name for the quadrilateral with vertices, blah, 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 blah. Now, you could sketch it out. I'm not going to take the time. But, you know, I will tell you, it does go around kind of in order. In other words, A, B, C, D. If you go clockwise or counterclockwise, they will go in order. So let's usually when we do problems like this, we look at the slopes. Okay. So let's find the slope of AB. Let's find the slope of the opposite side, CD. Then let's do BC and AD. Again, you could sketch it out if you want to create a visual. But the slope of AB ends up being negative 6/4. Now I know that does reduce. And this is negative 6/4 as well. So that means that those sides are parallel. And then here you get 4/6 and 4/6. So these are parallel as well. So both pairs of opposite sides are parallel, therefore you have a p-gram, right? Now we have to explore to see if we have something more than that. Well, one thing you notice is look at these slopes. They're opposite reciprocals. So consecutive sides have opposite reciprocal slopes. Therefore, you must have at least a rectangle now. Okay, because you got right angles in the corners. Now we just have to see, I mean, the next thing would be a square. Okay, so let's see if we have a rhombus. Now you could do distance formula here to check the length of the consecutive sides, and if they're congruent, they're a rhombus. I want you to realize you could also look at the slopes of the diagonals. The slope of AC is negative 2/10, and the slope of BD is 10/2, and those are opposite reciprocals. So the diagonals must be perpendicular. And if you have a rectangle with diagonals that are perpendicular, that means it's got to be a rhombus, which means it has to be a square. Okay? You actually ended up with a square here. You're not always, it's hard to get a square. It takes a lot of, it can be tricky. That's called a coordinate proof, though. You're going to see some more of those later. Okay? So coordinate proof, remember, is not a two-column proof. These are cool. These are box problems. You know, you're asked to write down what is the most descriptive name for each quad below based on the tick marks and the given information. You should stop. This right now and see if you can do this yourself. Okay. And I'm going to talk about, I'll give you the answers and talk about a couple of them. This thing here ends up being a trapezoid. And that's it, because you got one pair of opposite sides parallel. That one angle being bisected doesn't tell you enough to do anything else. This is also trapezoid. You got one pair of opposite sides being parallel. Now, I know that's a right angle down there. In other words, this is what you potentially have. You see? There you go. Now look at these tick marks. These tick marks show that the diagonals bisect each other. So right away you have a parallelogram. but then one of the angles, and this goes back to the front page of your sheet, one of the angles has been bisected by the diagonal. So this is a rhombus. Go back to the front of the 7.6 sheet if you're confused. Here we have a parallelogram based on these tick marks, but then you have these consecutive angles are congruent. And then opposite angles are congruent. So all four of these angles are congruent. This has to be a rectangle. Now here, diagonals bisect each other, but look, all these tick marks are the same. So not only do the diagonals bisect each other, the diagonals are congruent. So that means you have to have a rectangle, but then the diagonals are perpendicular. This ends up being a square. And this last one is an isotrap. All right. I'm going to do this one quickly. You do know that, let's see. Let's look at the AB's. This is isosceles with base ace. Come on. ABC is a right angle. Okay, so the fact that these bisect each other, right away, ABCE is a parallelogram. Okay. If diagonals bisect each other, then a parallelogram. Okay. Now, what else can we do? ABCE is a rectangle. If P-gram, with one right angle, then rectangle. Okay, now if that's a rectangle, that means that BC is congruent to AB. Well, that's not because of the rectangle, but if isosceles triangle, remember going back to the given information, if isosceles triangle, then you have those sides. So now we can say that ABCE is a rhombus because if P-gram and consecutive sides congruent, then you have a rhombus, and now we can say it's a square, right? Because if quad is both a rectangle, which we did that in step 3, and a rhombus in step 5, then you have a square. Okay. So in problem 9, I'm not going to do that one. I had it down as a 5-step proof, and you can mess with the last problem as well if you like. Sorry about the numbering. I'm not too sure why it's numbered all out of whack. And then there's a second document. There's not going to be a video for that. The second document that we did for today's lesson, those solutions will just be posted on Canvas.